determining the speed of an object in uniform circular motion due to the gravitational force from another object. What speed should a satellite with a mass of 1,500 kilograms at 8,500 kilometers above the center of the Earth be traveling at in order to stay in orbit? Remember, the mass of the Earth is 5.97 times 10 to the 24th kilograms. All right, let's write down our key information first. Our satellite, we're just going to make this M1, and that's 1,500 kilograms. Our radius is 8,500 kilometers, and we want to change this to meters. Once we change this to meters, we get a completely different value. We get 8,500,000 meters, and M2 is the mass of the Earth, 5.97 times 10 to the 24th kilograms. And that's basically all we need. Now, let's look at two different equations here. We have the centripetal force equation, which we remember from the previous unit, which is mv squared divided by r, and we also have the new gravitational equation, which we just learned, and that's capital G, and we're going to make this m1 because we're talking about the satellite, m1, m2 over r squared. Now, we have two different formulas here. This is for centripetal force, and this is for the gravitational force. Now, if we look at a mini diagram, I'm going to draw. This is the Earth, and you have a satellite orbiting the Earth. The satellite's traveling in uniform circular motion. What's actually causing the satellite to travel in uniform circular motion is the gravitational force, which is pulling the satellite towards the center of the Earth. So by virtue of the fact that there's a gravitational force here, this gravitational force acts as the centripetal force. So Fg equals Fc. Now let's set these two equations equal to each other. So mv squared, m1 over r equals g m1 m2 over r squared. Once we set these equal to each other, we can solve for v, and we get a new expression for v, which is equal to g m1 over r. And that's our equation for velocity. So that tells you the velocity that this satellite needs to travel in order to stay in orbit. Once we plug in the key information, we get a speed of 6.8 times 10 to the third meters per second. And that's how fast that satellite needs to move in uniform circular motion in order to stay in orbit.